So now we're going to take a look at the passive first order high pass filter. So all we're really doing is we're swapping the R and the C roundabout, and that makes it into a high pass filter. So again, the simple look at this here, but the input is here, V in as a function of S, and V out is across the resistor there. So we can say that V out is equal to the resistance here divided by the sum of the R plus 1 upon CS. So we've seen that in the previous videos, and if we know our way, just do a little bit of algebra and shuffle the algebra round about, we get the V out upon V in is equal to RCS upon 1 plus RCS, and this is a high pass filter. Now make sure you go through and just go through the algebra yourself to confirm that you understand it. Now we can also write that in terms of the frequency, just replacing the S by the J omega. Okay, now what we're interested in is where the poles and zeros are. So from this here, the poles going to be whenever the denominator is equal to 0. So 1 upon 1 plus RCS got to equal 0, so S got to equal minus 1 upon RC. So again, you've got a pole at minus 1 upon RC, but the difference between this one and the low pass filter is that now you're going to have a 0 whenever S is equal to 0 here in the numerator. So when RCS equals 0, then S is going to equal 0. So we've got a 0 there at the origin. So now we've got a pole there. So when we looked at the low pass filter, we had only one single pole, but now we've got another, like a 0 placed at the origin. So that 0 there is going to tend to make this a low pass, a high pass filter. So if we were to draw it out in terms of a magnitude response and a phase response, we would have no frequencies passing at low frequencies, and only the frequencies passing at high frequencies would get through, and we see the phase associated with it here as well. Now I've built this up in multi-sim. Okay, so we'll have a look at that in a second, but there's the AC sweep for it, and you can see it's a low pass here, and the amplitude, the magnitude, and the phase here as well. You can see the phase, the same as what we have suggested up above here. Okay, so we'll have a wee quick look at it in multi-sim, but remember it's such a simple circuit here. It's not much different from the previous circuits. So that's the circuit in multi-sim. I'll just expand it up a little bit so we can see it. Now all I've done is swap the R and the C roundabout. I've still got this thing in here. We don't really need it for this simulation, but we can use it if we want to create the bode plot. So I'll show you if we again click on simulate and analysis and simulation, and AC sweep. We save that, we can then run it, and you can see it's generating this high pass filter here. Okay, just the computer's running a little bit slow, that's why it's taking the time to draw this out. I've got other processes running, but that's the same as we've just seen in the previous setup there. Okay, so we can also go in here if we want to, and back into simulation, and we can analyze and simulate, and we can go back to just interactive simulation, and we'll save that, and that'll allow us to then just click on the bode plots, and we need to actually run it, so we'll run it first, and that gives us the bode plot. So you can see that there again is going to be the high pass filter, and you can see the phase as well. Make it a bit bigger. You can see the phase, clicking on the phase there, and then it's drawn out the phase response for us as well, just as we've seen and a couple of minutes ago. Okay, so that's all there is for this video, and I'll get you on the next video. Okay, goodbye.